Basically, we'll do a quick announcement summary. We'll look at the line of servers, what's involved with upgrading, and a little bit on PDU planning. So on October 6th, IBM announced the follow-on to the Power 7 enterprise servers. In April or May, I always forget, they announced the scale-out servers, which were the replacements for the 710, 720, 730, 740, and in my view, the 750 and 760. So these would be the 812, 814, etc. And they announced some small Linux-only boxes. In the October announcement, they basically announced the two new enterprise-class systems, the E870 and E880, with different availability levels. So the 870 and the 880, which are 1 to 2 nodes, are available 18th of November, but the 3rd and 4th node on an 880 aren't available till June next year. They also announced an update to the scale-out 824L and some RPQs and so on. I'm not going to really go into the RPQs and everything for using 110 volt. I'm more interested in sort of focusing on the line right now. So, if you look here, these Power 8 scale-out servers are really replacing the older 710s. The 824, which is the bigger of the scale-out servers, is bigger than the 750, 760 plus in terms of RPF. So to me, this yellow line should really come up to here. The 770, 780, and 795 are being replaced with the scale-up servers. And the biggest change there is that the 795 is a 24-inch rack, 770, 780 are 19-inch racks, and they're node-based. The scale-up servers that replace all three of those will be in a 19-inch rack, and they are node-based again. So they're not planning on bringing out a 24-inch rack anything. Instead, 770, 780, and 795 will be replaced by these new scale-outs. Nothing has been announced for the PureFlex, and we're not getting any answers on whether there will ever be a Power 8 node for the PureFlex. So I'm sort of sticking with the scale-out servers right now. In terms of the scale-out servers, this is just a list of what we have today. There's basically two flavors. The S is for scale-out, the 8 is for Power 8, the 1 is for the number of sockets, and the 4 here is for the number of U. So the names actually mean something, which is kind of bizarre. So I've just got some basic details here on how many sockets, etc., how many U. The ones that end with an L are Linux only. So they actually, and what they do with the Linux only boxes is they add some additional discounts. So if you really want to run Power Linux, it is less expensive to run it on an 822L than it is on an 822, even though it's pretty close to the same box. They also announced an 824L, which is the 20 or 24 core, 4U, 2-socket with up to a terabyte of memory. And basically the way that they've got the memory set right now is on most of these scale-out servers, it's 512 gig per socket. So if you have 2 sockets, you can have a terabyte, which if you think about it, means that this little 822 can have a terabyte of memory. That's a lot of memory. They did make a change to the 824, and I believe it can go to 2 terabytes now with 2 sockets. One thing they did in this new 824L is they added a special NVIDIA GPU. This is for people that are doing Linux-based calculations, etc. So they made a huge change to, if you have this GPU in, the floating point performance is dramatically increased. They've also gone, with Power 7 we had to go through an I/O bridge and we're PCIe Gen 2 into the chip. We now with Power 8 are directly PCIe Gen 3, which makes a big difference to performance. We got rid of the GX bus, so we don't have those GX adapters anymore. That also means that GX attached I/O drawers don't connect. And in fact, right now for the scale-out servers, there is no I/O drawer. All right, so what did we do with the enterprise level? That was the scale-out. This is called the scale-up. So they took specific attributes from the 795 and from the 770, 780 and created the enterprise 870 and 880 using those. So as an example, the 795 used a mid-plane to interconnect all of the CPUs and to take care of some of the redundancy. With the 770s and 780s, you had to have 2 nodes to get redundancy because the system clocks, oscillators, service processors, there would be one in the primary node and one in the secondary node, and then the other 2 nodes were just additional nodes. With the enterprise class, they've gone with a mid-plane architecture like the 795, and all nodes are equal. So what that means is, unlike with a 770 or 780 where I had to have 2 nodes to have redundancy, with the enterprise 870 or 880, I could have 1 node and have redundancy, and I'll show you how we do that in a second. So with the rollout, basically, as of right now, we can go to a 1 or 2 node 880. You can migrate a 780 to an 880 with a single serial number upgrade. You can migrate a 770 to an 870 with a single serial number upgrade. There is no single serial number upgrade from a 795, but it will end up being a 4 node 880. So one of the things that they've done is, with the scale-out servers, they're using dual chip modules, so that in each socket you actually get dual chips. With the enterprise servers, they're actually single chip modules. You still end up with the same amount of level 3 cache, the same number of memory attachments, etc. But it is one of the main differences between the scale-outs and the enterprise. And this is just really showing you the same picture. And I already talked about the positioning, so you can see 770 goes to an 870. A 780 could go to an 870 or an 880, but I will tell you that from an upgrade point of view, if you want same serial number upgrade, it's going to have to go to an 880. What we'll see when these boxes get maxed out is that an 880 is going to have a maximum of 4 nodes and then this little midplane. Each of these nodes is 5U, not 4U, and the midplane is 2U. And as I said, they go into a 19-inch rack. So if we look at the building blocks, each node or KEC is 5U. It has 8 PCIe Gen 3 low-profile slots. So you could bring low-profile cards across from other servers, but be aware that they are low-profile. There are no disk bays. So whereas a 770 or 780, you had 6 disk bays in each KEC, there are no disk bays in these. So you either have to boot from SAN or you have to add an expansion drawer. There's a 5887 expansion drawer that has, I think it's 24 disk bays, and it can be divided up so that you can connect it to 4 different LPARs if you want. So if you want to boot from internal disk, then you're going to have to add a disk drawer. And as I said initially, you're only going to have up to 2 nodes on either an 870 or an 880. Come 2015, probably June, it'll be up to 4 nodes on the 880. You can't take current I/O drawers and connect them. There is a PCIe Gen 3 I/O expansion drawer that has 12 slots per drawer. So if you need more than the 8 that are in each node, you can add these I/O drawers. Right now today, you have to add either 0 or 2 I/O drawers per node. That's a testing statement. They've only tested 0 or 2. They haven't tested 1 or 3. So later on, they're going to fix that, but right now your option is 0 or 2 I/O drawers. So I mentioned that each of these KECs is not in a 19-inch rack and 5Us. It has up to 4 sockets and up to 12 cores per socket. There's a bunch of different options. Also up to 4 terabytes of memory per node. So a 2-node E870 could have 8 terabytes. The bandwidth is phenomenal for the memory, and I'll show you some comparisons in a little bit. Oops. And the other thing is it has 4 power supplies. It's a 2+2 configuration. It does draw a lot more power. So one of the things you will have to pay attention to is power and cooling. And I have some numbers on that further down. The system control unit, which you have to have one of, is 2U. That's where your service processors, vital product data clocks, etc. will be. You'll hear it referred to as an SCU or a midplane. These are just some of the attributes of the 870, and then again for the 880. Really the main difference is some of the CPU speeds, and the 880 long-term will be able to go to 4 drawers, the 870 only to 2. This is just giving you an idea of what the different options will be. So the 870 right now, you can get a 32-core version or a 40-core version, and then of course if you have two nodes, 64 or 80 cores. Just to give you a feel for it, this 32-core version is about 630 RPerf, which is pretty powerful. And then in terms of the 880, we only have the 32 or 64-core version at this point. The plan is to expand it to a 128-core version, and there's a statement of direction for 48 cores per node. I mentioned that the slots for PCIe Gen 3, they're all 16-lane slots, which means that you're going to get more performance through them. You'll also see the connections here to the service processors and clocks. This is what a full-blown system would look like. So the initial KEC is this one here. Then we have our mid-plane, and then we would have our second KEC below it. And then you'll add the third and the fourth in 2015 if it's an E880. So our mid-plane is 2U. It has our service processors, our clocks, our oscillators. So all this, and they're redundant in there. So what that means is that if you lost a clock in the system control unit, you would still have the other clock running. It also has an optional DVD, which can be assigned to any of the LPARs. And basically every node is equal and they're all connected to this mid-plane. The mid-plane gets its power from the nodes that it's connected to, so it does not have its own power supplies. That's why you don't see power connection supplies here. This is just showing you a similar thing. By the way, these have to be physically adjacent, because you can see with the interconnections. So this would require 22U in one chunk, and it's not going to be at the top of the rack. So this is just talking about some of the redundancy, and again, it's really, with one node and one SCU, you get redundant system clocks, you get redundant oscillators, service processors, redundant power sources, etc. And there's the one operator panel, but the HMC can replace that. There's a VPD card, which takes care of the vital product data, and so on. Oh, actually, one thing that they mention here is if you do add the DVD, you will need a couple of special power cords to have enough power for the DVD. So I mentioned there was a PCIe I/O drawer. That is a 4U I/O drawer, and it has 12 PCIe Gen 3 slots. Some of them are 8-lane, some of them are 16-lane. It uses dual power cords. It's really similar to the I/O drawers we had today, except for it uses this new optical interface instead of the old GX Plus stuff. Another comment is that IBM will build these resources in a 42U IBM rack at the factory. So if you plan to put this in your own racks that aren't IBM 7014 T42s, there's a code that we have to enter to do that. And they were talking about doing a chargeable deracking feature because they build it in a rack and test everything together. So that's something we'll check for, but there are very, very specific requirements for non-IBM racks because these are heavier. They have very specific rules about the hole spacing, etc. So that's something, if you're looking at getting these, that you should check with. This is just the operating system versions that will be supported in order to run the 870, including there's a new VIO server release that's coming out and some new firmware, etc. What this slide gives you an idea of is the different reliability, serviceability features. So when you start getting up to the 870 and 880, that's when you start to see things like active memory mirroring for the hypervisor and some of the redundant service processors, etc. Also, the 870 and 880 require an HMC. And they can also participate in enterprise pools. So, for instance, 770s and 870s can live in the same mobility pool. 780s and 880s can live in the same mobility pool. So, just things to think about. I put this in to give you an idea of some of the performance. IBM published SMT8 4, 2, and 1 performance numbers for the scale-outs. They didn't publish them for the scale-ups. They only published the SMT8 numbers. So I used the same percentages to figure out what they would be for SMT4, 2, and 1. That's why it says estimates. So if I look at an 824 with 24 cores, it's 394 RPerf. My 20-core 822 is 323. My 32-core little baby 870 is 630. So it's pretty close to two of these 822s in terms of performance in 5U, or 7U if you include the SCU. If I compare that to a 770 32-core, that was 410 and I'm sitting at 630. So, but that required 2 kicks. So just some interesting comparisons for you to think about in terms of your ability to scale. A couple of comments on upgrading. The only models that can be upgraded are the D models of the 770 and 780. So if you currently have 770Bs or Cs, they need to be upgraded to a D model before you can upgrade them to a 870 or 880, and that's a typo. That should be 870. When you do that, when you do the same serial number conversion, what actually happens? Pretty much if you have whatever processor features you have, let's say you have 16 cores, those processor features will go across. So they just convert, and you pay a conversion fee versus a purchase fee. There are processor activation features, memory activation features, and so on. Those will come across. The kick and closure, so that feature comes across, but the actual kick and closure can't come across because a 770 kick is 4U and an 870 kick is 5U. So really almost nothing comes across specifically, like as in terms of hardware. It's really the actual features that come across. You know, if you have IBMI enablements, if you have active memory expansion features, those will come across. And of course your AIX licenses will transfer. Now, one of the things you can do is you can actually do what we call a side-by-side RPQ, where they build them at the same time. So they build the new one and then they move you over. Keep in mind when you do that, you have 2 servers running with the same serial number. You have to have 2 separate HMCs. You cannot have them both connected to the same HMC if you're going to do this side-by-side, because the HMC is going to see 2 servers with the same serial number, and it's going to get very, very confused. We're running into the tail end, and I just want to mention this CAPI attached flash. So this was something else that they announced. It's the ability to take advantage of the new CAPI interface to attach a flash system to a Power 8. So pretty much what it means is that it's going to sit somewhere in terms of performance between around the level 4 cache rate, maybe a little slower. But it's a way of doing reads and writes through the CAPI adapter instead of going all the way out through the disk and I/O and LVM adapters through here. It pretty much lets you treat your flash like up to 40 terabytes of extended memory. And because of the way the connection takes place through CAPI, through here using a shared memory work queue, you're actually getting rid of about 97% of the code path that's normally required to do a read or write. So, you know, the comment they make here is that 20,000 instructions, which is what you go through on the left here, have been reduced to less than 500. So there's a lot more information out there about CAPI, and they call it the NoSQL stuff. We can get that for you if you're interested. Just let us know. And this is really what these are talking about, is the new NoSQL KVS and how it all works. So what you're seeing here is the Power 8 server connected directly into the flash and using it pretty much for as high-performance memory extension. And this just gives you an idea of the performance difference. So if I was to attach that same flash using PCIe, I'd get around 16,000 or so IOs per second versus 108,000 via CAPI. And that's on an S822, which is a little scale out. All right, a couple of other things to keep in mind. If you're looking at the 870 or 880, the PVUs for any of your Passport Advantage software, which is typically your WebSpheres, etc., is 120. The warranty by default for the scale-up is 1 year, 724. You can bump that up to 3 years if you want. For the scale-outs, it's 3 year, 9 to 5 next business day. So you may want to bump that up to 724. A couple of comparisons. If you look at a 770 MMD, if you look at the memory bandwidth, it's around 272 gigabytes per second per node. It is more than 3 times that on an 870 per node. It's like 922. And then the I/O bandwidth is also significantly higher. This is where a lot of the new performance benefits are going to come in. It's not from the difference between a 3.8 gigahertz and 4.19 gigahertz CPU. It's from the way they've architected the memory and the way we're now doing PCIe Gen 3 without GX adapters and so on. We can now drive a great deal more bandwidth, which means that we can, which is important when you want to start adding things like flash to the environment. And this is just throwing the 880 into the mix. So, I compare a 770, 780 to an 880, and these are kind of like the differences you see again, significant performance improvement in the memory and I/O bandwidth. Remembering that the memory bandwidth is dependent on filling all the memory DIMMs. All right, a couple of last notes in terms of PDUs. And the one thing I'll say on TDAs is a technical delivery assessments. If you're looking at buying a E870 or an E880, then whether it's IBM or a business partner, they should be doing a TDA with you. And TDAs are done to make sure that the configuration is what you want, plus that there are no errors in it, and that things like the power requirements, etc., are clearly spelled out. So to give you an example, the D model Power 7s and the new HMC and the Power 8 servers use more power than people were thinking. And there's typically two types of PDUs that people, or line cords for them that people use. One is 60 amps and one is 30 amps. In the US, by law, we derate those, so you can't put 60 amps to a 60 amp PDU. The maximum you're allowed to plan for is 48, and for 30 amp it's 24. That was done in the US because people were overloading them and causing fires. So you should always look at them really as being 48 and 24. Every server has 2 power supplies, or in the case of some of the Power 8s, 4. And it's in the case of the 4 ones, it's a 2+2 environment. They have to go to 2 separate PDUs for redundancy. And you have to assume that either side could be drawing the power. So even though only one side's really going to be drawing it, you have to assume each time. So you cannot overload the PDUs, because if everybody started to draw on one PDU, you would end up with a fire or a circuit breaker going. So, and that's what we're talking about here. Because if a PDU and a redundant pair fails, you could run into situations of overloading. So that's one of the reasons why you end up planning for more than you're actually going to use. And there's in the actual red book for the E870, E880, they actually go into a lot of detail about this. But pretty much, if you're looking at it for planning, and I do see a question from somebody, I'll get to that in a couple of minutes. If I look at a 770-780D, each node requires 1900 watts or close to 2 kVA, which is about 9.8 amps. With an 870, I'm talking 21 amps. So it's it's just over double. And what that tells you is if you're using 30 amp PDUs, I can only have one node on each pair of PDUs because I could draw 21 amps from either side. So just be a little aware of that. Now, having said that, you're twice the performance of the 770 anyway. So realistically, in one node, I'm drawing the power but providing the performance that I would get in 2 nodes on a 770. But just be aware about this because you don't want to get caught up with not having enough resources. And then I have the weights of the SCU and the IO drawer, etc. So the comment down here is IBM's official support for a 30 amp, which is PDU, is that it will support 2 system node power supplies. Well, remember each node has 4 and 1 IO drawer. So that's all that you can put on there is 1 node and 1 IO drawer for 2 PDUs. So I just wanted to bring that up to your attention because we really need to plan properly for power. And it also speaks to why there's a big push to get people to move to 60 amp versus 30 amp because you don't want to have a gazillion PDUs.